So the partitioned subnetwork. What's important to understand about partitioned subnetworks, each feature in that partitioned domain network is that it only participates in a single subnetwork or a single tier, right? It's logically partitioned at some logical breakpoint. So for this electric example, subtransmission through the substation, medium voltage and low voltage. So again, if we look at the bigger picture, from electric, you've got generation to transmission all the way down to secondary distribution. In European models, they often look at it based upon voltage levels. So they could possibly model their domain network with tiers that represent specific voltage ranges. So a different way to cookie cut those same domain network and features. Now in a hierarchical domain network, these are different. Why they're different is because the tiers and the system being meshed and looped, the features themselves participate in multiple tiers. So from a gas network perspective, it's a system of pipes. Maybe I'm a distribution company. I may manage 16 or 20 different systems. And these systems are geographically disjoint from each other because they're connected to some transmission provider. So they're disjoint systems, and they each have a name, maybe their geographic name or village that they're serving. But then within the system of pipes, we have pressure zones. And then within pressure zones, we could have multiple isolation zones. The individual pipe is actually then participating in each one of those, right? That pipe that's in our going down the street here is in an isolation zone, but it's also running under some pressure level as well as participating in some system level. So why that's important is because we have an attribute called subnetwork name that's on each feature class, which stores the name of the subnetwork. And I'll start showing that in a little bit after we get through some more slides and another demo. So the important thing with pressure networks and how to model a lot of this came down to how do we manage a pipe? And because pipes can live in all different types of zones, and a pipe could live in a gathering field, it could live in transmission or distribution. So many ways to model these domain networks. On the hierarchical domain network, right? So if we highlight these, even though it's hierarchical, in a sense, where we're partitioned are these tier groups. We have a group of gathering, we have a group of transmission, and a groups of distribution. These are called tier groups. And then within there, we have the tiers. Just like we had in partition, it's a collection of hierarchical tiers, where it can be the system, the pressure, and isolation. So what's interesting about these hierarchicals, we're slicing it in two directions. All right, I talked about sources and sinks, how you must define the domain network, what it will represent at the point of creating the domain network. The geoprocessing tool that we have for creating the tier group. So tier groups only apply to hierarchical, not partitioned. And the reason why we have the groups is a way to cookie cut these, partition them into their logical collections, be it gathering, transmission, or distribution. And then within each of those, the tiers themselves. As well as cathodic protection is a type of tier group and tier. When we add tiers, we have to give a name, 64 characters. We have a rank. They're beginning assigned at 1 in partition and within each tier that's added to tier groups. And then the topology type. For partition, you have radial or mesh to choose, whereas in hierarchical, they're always mesh. They're always looped. Bless you. Now, the subnetwork field name. This is the field that is created on each feature class in the domain network. It's the field that's going to store the subnetwork name that the feature participates in. Well, for partition, like I said, that feature can only ever participate in one subnetwork, right? Because we're logically partitioned into little groupings. But in hierarchical, that pipe that can participate in multiples, it has to have multiple subnetwork name fields. Therefore, when adding a tier, if it's a hierarchical domain network, you'll have this additional argument to provide the name of the subnetwork field that will be added to the feature class and will be populated when we run update subnetworks. The difference between topology types, this is specific for partition. I kind of touched upon that, the radial mesh examples. If you know your radial as opposed to mesh expecting loops, that's important because when we do tracing tomorrow, Rick and Deb will talk about the importance of knowing that we're in a mesh tier, what the expected results should be in those cases. Again, I showed you before this on the property pages, different ways to organize your tiers within the domain network. This is an example for a partition domain network. Here's an example for hierarchical domain networks with its tier groups and tiers within. The structured network, it does not have tiers or subnetworks, right? They are used to support the domain networks we're modeling. Everything Eric talked about this morning, right? Structures are what support, be it a pole, a vault, a substation, a duct. Now, you can still trace on the structure network, right? Perfect example would be a duct capacity trace. I want to pull a wire underground from location A to B. What are all the valuable optional paths that I can use to pull the wire through the underground ducts? Well, I can do a trace, and hopefully Rick will show that tomorrow, a path trace. I mentioned the subnetwork controller category. This is a system-provided category because we're explicitly looking for that category assigned to devices when giving you the choice to choose what are the valid controllers. I kind of showed you this already on the properties page, showing the category that's listed. The subnetwork definition. These were the things that define the properties of the subnetwork. I kind of highlighted what are the valid devices, the valid lines. Now, what will happen is when we update subnetworks as part of the workflow, if we discover features, because when you say update this subnetwork and you give us the name of the subnetwork you want us to update, we'll do that trace and we discover everything that's connected based on that trace configuration, when to stop at an open switch or when to stop at a closed valve. We have then that collection of features, and if we discover any feature in there by asset group and asset type which is not defined as being valid, we return an error during update subnetworks and we generate an error feature, be it a line error or point error feature. So again, it's about data correctness and consistency, and how can the system represent the real world, and what can we put in place for mistakes that happen while editing, right? It's a good way to keep data cleanup occurring through the workflow. Now, the support disjoint one, I went over that really quick on the properties page because it's easier to show a picture than to speak to it. And what this is saying is that when we have a subnetwork, may it be disjoint or not? Now, a subnetwork may have multiple subnetwork controllers, right? So a mesh, these are highly redundantly fed subnetworks of our network that you often find in downtown business areas, right? Because you have all the critical infrastructure down there. So it's highly looped and redundant. So there's multiple controllers. Or you can have radials in the substation where you may have the same subnetwork with multiple circuit breakers in there in case one fails. But we need to know, do you want to support the case of those controllers being disjoint, meaning no connectivity between them? Because we know at times, in the case of a mesh, that there can be parts of the subnetwork, the features literally, deleted and removed that cause islands to be disjointed, no connectivity, connectivity and not traversability. Traversability, I just said that backwards. Traversability between the two, meaning for these collection of controllers, do we have a valid trace path based on traversability that gives us connectivity. And if not, we can raise errors. Talked about the valid devices, controllers, and lines. These are all properties that you set. Now, one of the things that's very important, I'll say this now before I forget, is that, of course, you may deploy the model in June, be in production for several months, and then maybe discover you're missing a different type of device that you want to model in your system. That's a case where we're going to have to come in, add that additional asset group subtype value, define the asset type and the domains, but then we need to come back and modify the subnetwork definition to say, hey, I now need to add this additional device as a valid device in my subnetwork. So as the administrator, the owner, I have the ability to disable the topology in the default version and then open the set subnetwork definition geoprocessing tool and change the configuration and then essentially apply it and then re-enable my topology. So that's how we can support changes in the model. All right, I talked about the trace configuration. I talked a little bit about propagators. I'll show that example in a demo coming up. Oops, going quick. And then I talked about the summaries. Did I have the summaries on here? No, we'll come back to the summaries. I highlighted the fact of how you can have these summaries that are discovered and stored on the subnet line feature class. Now, devices are the only features that can be subnetwork controllers. In the terminal discussion, Rick talked about how a subnetwork controller must have terminals. Now that's very important because the terminal configuration has a property to tell us what's upstream, what terminal represents the upstream side, or if that terminal configuration is bidirectional. That becomes very important then when we build out our subnetworks to know the terminal on this device is upstream, and this may be, for example, the load side. So I have a terminal configuration in here which has just two terminals, one called the source side, one called the load side. So the load side would represent the medium voltage distribution circuit, where the source side can only connect to the substation side of features, right? So we have rules to define what can connect. Therefore, when we want to trace that subnetwork, guess what we know right away? When we start at that device with terminals and we know what terminal's upstream and we want to go, and we're a source-based network, guess what direction we want to go? We want to go downstream, away from the upstream side, and vice versa in a sync model. In a sync model where we have the treatment plant, those controllers would be our sinks, therefore we'd be specifying knowing the upstream, downstream side, and given what type of domain network is, we know then the direction of the trace. There's other properties. We know we have an attribute on the device that tells us the subnetwork controller, its name, what tier name and tier rank it participates in. I'm going to show you this now, how we actually create subnetwork controllers and edit those. Any questions? Any questions from the online? Is anybody watching those guys? All good. It's already 8:17 on the 7:17 on the East Coast, so they went home. All right, so I'm going to zoom. First thing I'm going to do, I'm going to turn my visibility. I'm going to keep that on, actually. I'm going to go back to my Find Subnetworks, and remember I had activated Subnetwork 107 by hitting reset. That essentially turns off that filter, returns everything back to the normal display. And because my content is all displayed, I'm going to zoom into the substation where I can see all the individual buses and circuit breakers and all the connection points. So let's zoom in tight here. So this is actually Sempra's data of how they've been using CAD and the GIS to keep track of all the features in the substation. And we essentially took that data and poured it into the utility network so we could have connectivity all the way out through subtransmission and their transmission features that they gave us. So the features with the big B are my circuit breakers. They're the source. So as my labeling quickly jumped around there, here's a case where I've got circuit 124, and these are their actual names, have multiple, 3 different circuit breakers are used as sources in the case of 124. So they all share that same subnetwork name, but their controller names are different. So maybe this is a good one to show you. If I identify that breaker, and this pops up, we can see what does this tell us. Okay, it tells us, of course, the asset group is circuit breaker. I knew that because I knew how I configured this really well. We know the subnetwork controller name. It's on the load side terminal. That's the name of the terminal that's assigned to the circuit breakers, air-powered circuit breakers. The name of the controller itself was 124A. So I'm pretty sure the other ones are named 124B, 124C. Pretty easy to follow. We then know that circuit breaker is a source in the medium voltage. And then we also know different properties that describe it and so forth, the usual attributes. So let's actually zoom in a little bit more. And now, first thing we're going to do, we're going to build out a very short circuit. So let's go ahead and create a feature, circuit breaker. So I'm searching there. We want it to be air powered. We can come over and drop that on the map. All right, now we have a circuit breaker, created the dirty feature. And the very other feature we're going to attach to this is the underground 3-phase cable that comes up, snaps to the circuit breaker, and we'll go that far. Now, one of the things I have enabled in my map are label expressions. I'm just dynamically using an arcade expression to take the subnetwork name, and right now it's unknown for this line feature. This is a type of wire, number 4, whatever that means in the electric world. CU is the material type copper, tells me it's 3-phase. It also indicates that it's currently de-energized and it has a default length of 100 feet. If we also click on the circuit breaker to pop up its values. Right now, right? Is it a subnetwork controller name? Well, it's unknown. Well, no, it's not then, if that property is not set. So now let's use the modify controller tool. So creating subnetworks is really a special event. These guys in these organizations don't every day just decide, hey, let's create a circuit breaker and build a circuit, right? That's a major capital improvement project. So it's not too often users would be doing these type of editing operations. Maybe they only have a few users who know how to edit inside this substation who would create these. Remy's waving his hand with a question.
Yeah, Tom, I've got an online question. Brian asked if you're using the new AutoCAD integrator for the CAD data that was provided.
No. All right, so yeah, I've got nothing else to add to that. No, I just copied the data in. It came from a geometric network, and I just copied the feature class and appended the features in. But that's a whole topic for Friday, data migration and the workbenches and the tools available there. All right, so again, even in hierarchical domain networks, right, these organizations build out these models. Yes, they'll have changes in their pressure zones, but as they engineer these systems and build out, right, that's when these type of editing steps will occur, when they'll occur. So here I go. I want to make this a subnetwork controller. So let me clear this, clear the selection. So I select my circuit breaker. Get back here. Let me pin that dialog. Okay, so the very first thing it knows, the intelligence of this tool, is that, all right, you've selected a circuit breaker of type air-powered. It essentially knows what are the tiers and what are the terminals that may be the subnetwork controller. So right away it tells me, oh, it can only be on the load side. But it does give me a choice to say, well, which tier? That breaker could be a controller in subtransmission or medium voltage. Notice it didn't allow me to set it as a controller for the low voltage tier, right? Because it's not based on our valid subnetwork controller configuration. All right, so we need to give it a name. Subnetwork controller name. Let's call it Tom's Breaker, because I'm in the substation in Old Town San Diego. And I also need to give it a subnetwork name. Now, the difference between the controller name, right? That's the actual name that describes that individual device, whereas the subnetwork name is the value that's going to be stored in that subnetwork name field for all the features that participate in the subnetwork. So again, we'll just call it Tom's. Wow, got caps lock. Get out of there. Turn that off. Well, that's interesting. Okay, found a bug as we demo this. Don't uppercase those. All right, we're going to go with Tom's lowercase. It was trying to autocomplete based on the name. Now we hit apply. So at this point, all we're doing is calling the REST endpoint that says, make this, and this is a REST endpoint on the utility network service that says, make this a controller. Enable it as a controller. We also have a disable operation on the REST endpoint. Now, if we go back and identify this feature, you will now see that it properly updated the subnetwork controller name, knowing that the terminal is on the load side for Tom's breaker. Now, the reason why we have that level of detail, there are devices, such as transformers, that could have multiple terminals, and the terminals themselves are different controllers of different subnetworks. So if I had a transformer with 3 different terminals, and this is common in Europe apparently, each of those terminals are a controller. Therefore, you would see on that device a comma delimited list that said, for this terminal, this is the name of the controller, comma, this terminal, the name of its controller. And then we'd see also that the circuit name, and I used an alias on my layer for the subnetwork name called operational circuit name, and you saw that it was populated with Tom's. That's the name of the subnetwork. Again, all of that behavior of setting those values didn't happen on the client side. So no matter what app was calling that REST endpoint, as you enable something as a controller, the side effect of making it a controller also updates all these additional fields on the server, and it's the behavior that we've taught Pro to get back those changes from the server in order to update the cache and the features on the client side. That will be discussed in detail in tomorrow's versioning and our transaction section, how that all works and why it's very important. All right, so now that we've done those 2 steps, well, you can still see we have dirty areas, so I need to go ahead and validate this. So hopefully this runs a lot faster than Rick's, and it did. That just shows you the surface is far more powerful than Rick's little Dell. Not many features to validate there. So we just created connectivity right between these things. Now, although I can trace this subnetwork. Let's just do that real quick. GeoTrace. I'm doing this the hard way. If I just click the subnetwork trace tool in the gallery, I can tell, hey, we're going to do electric distribution, we're going to do medium voltage, and I'm going to tell you the subnetwork name. Hopefully it's at the very bottom, Tom's, and we go ahead and run that trace, right? And now you'll see my selection set should include 2. Thank goodness it does, so I know the system is working perfectly. Now remember, one of the things I talked about was propagation. Propagation is in a very advanced configuration. It's not something that we're configuring in our subnetwork definitions with our asset packages. We've documented how propagation works. We are coming out with more documentation to show examples of how propagation would work in the electric, in the North American model, and how it could work in pressure networks and so forth. This data set is configured with propagation, being the phase value. So one of the things, if we click on the circuit breaker again, we can see I had a default value of the phases current be ABC, right? Because that's where all the electric comes. It starts at the substation and has each phase. And we're going to propagate that phase value down this line. Because if we look at the line itself, it doesn't know anything about what phase it is, right? Because a wire is just a wire, and it can change phase at any time based on how it's connected to its upstream devices. So the field that I'm labeling on is phase energized. Now that is a field that is maintained by the system during update subnetworks and propagation. So that's what I'm going to show you now. So we go ahead and clear. Now we're going to jump out to geoprocessing, and we're going to find my update subnetwork tool. And this is part of the workflow that we need to discuss, is that what points do I do these different steps? Well, is it after every edit I perform just because I have a dirty area? Should I validate? Well, no. Dave will talk about that tomorrow, about all the reasons why you need to validate at different times for the purpose of having connectivity and tracing. Or I may have validated, do I need to update my subnetwork right away? Well, maybe not, because I might be working in a version where updating the subnetwork isn't relevant. As opposed, I'm in the default version, which I've got all my viewing and my analytic applications reading against, where they need to see the most latest representation of the as-built features as versions are reconciled and posted, or the default version is directly edited. So in this case, I may be coming in a batch process that's running every hour. It's very unlikely I'll be doing this manually, right? Often a lot of the things that we show in our demos, we have to show you the bare minimal pieces that make up the system, right? So you understand these concepts. It's very likely an end user will never run update subnetworks. They'll have tools that the partners will build. They'll have tasks that will do it as a step, and they don't even know that it's happening as they step through the tasks. Or they may have batch processes that are just running, that are running on the server, just calling a job and constantly validating and updating the subnetworks in the default version. But for our purposes, so you understand the working pieces. So again, in the electric distribution, and then for the tier, I want medium voltage. One of the options that we have when updating subnetworks, I have a choice to say update all the subnetworks. Now, the subnetworks which I can update are only the dirty subnetworks. So by unchecking this, I'm going to show you the list of my dirty laundry, which are all the dirty subnetworks. A subnetwork is marked dirty during validate. When I validate the topology, we will fan out and discover what are the subnetwork controllers controlling the features that are being validated. That's how we then know to set a flag on every subnetwork saying, hey, you're now dirty. Right? That's the hook then to run these post-processing steps that are going to then update these other properties. All right, so we're focusing on TOMs right now. We go ahead and click run. We execute this real quickly. We can see it running. And again, this is all running on the server. We just called an endpoint on the utility network service, update subnetworks. We gave its name. Now, when that completed, you can see the map refreshed itself. And now you can actually see these additional labels change, right? The name of the subnetwork is TOMS, right? Same properties before, and the phases energized is ABC. That was the propagated value that started from the controller and propagated outward. So as a user, I never had to edit what are the phase values for this conductor, right? It's essentially inherited upstream. Update subnetworks writes those values to that field. Right? If we click on the line, we'll see the phase entered. If I click on the line, we'll see the value for phased energized is ABC now, right? It went from the default value of de-energized to ABC. More complex examples, for example, if I had a switch mid-span to this line somewhere, so it was literally two lines, and if I had opened that switch, which would have created a dirty area, I could have validated that, updated the topology, it would mark my controller dirty again, and if I were to run update subnetworks, the features that used to be part of the subnetwork, right, because the switch was previously closed to allow traversability, but then became opened, so logically they're no longer part of that circuit, they would have their subnetwork name set to the default value of unknown because they are no longer part of Tom's subnetwork. So that becomes how we connect the pieces where we started to see our aggregated geometries. So again, now if we come, oh, I touched my, if I come back to my find tool and now I refresh the list, oh, that was a complete failure. If I come over here, we got one more shot of fixing this bug. If I refresh my workspace, Go back to find subnetworks, refresh. I still did not get Tom's line. Okay. Got a bug happening there, caching bug. Where I'd have that subnet line there, and of course if I'm doing a circuit map, they would draw differently based on their colors and so forth. So you get the value of what we're maintaining there. Go back to slides. I got 11 more minutes to cover slides, which I've highlighted a lot of these. So I showed modifying the controller. We talked about the terminals that get assigned when you have to assign the controller. You have to pick what terminal based on the rules and the configuration. I'm going to give it subnetwork name. I optionally could have provided a description and notes about that controller. They often have more information that gets stored in our subnetworks table. What I didn't show was there was another button on the ribbon called View Subnetworks. All that does is open a nice table view in Pro that lists all the subnetworks in every domain network and every tier. It has the different attributes that can tell you the name, the tier rank, the topology type. In that dialog, you could also select one of those and say zoom to, and it will zoom to the controller of that subnetwork. So another nice way to navigate through the data. Those are all the different attributes I was highlighting that describe the subnetworks. Now, removing a subnetwork controller. Again, this is not an operation that occurs very often, very infrequent. But, of course, we still have to support it because eventually that device does get replaced. You have to select it. Essentially, we have the red X to allow you to delete it. But what's important is our next steps after a controller has been deleted. Well, if I've deleted the source, our subnetwork is still represented by that source and its name, the subnetwork name. Therefore, we have to run update subnetworks to remove that name from all those features. And then I'll talk about what it means to export a subnetwork and how that would delete it as a subnetwork in our collection. And I'm getting to export in a second. I'll come back to that. Okay, we talked about the editing behavior and how it creates the dirty area, and validation is what discovers the subnetworks that are dirty. One of the other properties that we have on the subnet line, anytime the controllers are marked dirty, we also mark the feature in the subnet line feature as dirty. Why? What does that provide us? A quick visualization technique. Now we can have a map that easily shows all the dirty subnetworks in red and all those that are still consistent in green. So in a dashboard application, I can see how people are editing and how the system is updating those and so forth. I talked about the update subnetwork, how I can either call that and say update all the subnetworks or just an individual subnetwork. That's all taking place on the server. There's also a check mark option that says continue on failure. Well, if I'm updating all of those, right, I have this option to say, well, if one were to fail because maybe it discovered an invalid device, do I want that whole process to stop or just continue on to the next subnetwork? Again, give and take about what the workflow is and how to report that back in these automated processes. We talked about the subnetwork name, right? If I had identified that line feature, remember I showed you, it showed you Tom's name on the subnetwork name field. Now, there are cases where we have features which are like the tie switches that separate multiple subnetworks. So here's an example zoomed into a tie switch in the switch gear. The tie switch is the yellow switch in that picture, where it has a subnetwork name 107 separated by the double colons and the 60. This tells us that the subnetwork 60 that you can see coming in from the bottom part has connectivity and it stops at that switch because it's open. Well, 107, its circuit also has connectivity to that switch, right, through the bus bar. Well, once that switch is closed, right, that's what allows the flow to come from either side. So that individual device actually participates in multiple circuits, multiple subnetworks. The 107 and 60 in red, that's the label for the container of the switch gear. Not only are we updating the subnetwork name on the junctions, device, and line features, also the assembly, which is the container. Often there are containers that may contain devices connected to different circuits and subnetworks. So again, we update it, and you would see multiple values there. That also becomes a very valuable way if you want to locate these features by doing a simple query in the application where subnetwork name contains double colons, right? You could easily generate a list of all your current tie switches. You could create advanced switching applications to know if I open this switch, this one better be closed so I can rebalance my circuit, or I can open and close valves to do isolations. The summary attributes, I showed those, how we can maintain those during update subnetwork. So given as we do the edits and we change the configuration of the subnetworks, update subnetwork will also calculate all those values at time and store them on the subnet line feature. A very quick reporting mechanism. Again, multiple summaries. You can have as many as you like. At some point, it will likely degrade performance. But you saw in the medium voltage case, I've got 20 different summaries, and it's still very efficient. The cost of us aggregating or whatever that function is that we're doing during the trace is very efficient, and Rick will show some of those examples tomorrow. The propagating of values, I showed that type, a very advanced concept. We're really dependent on our partners building the tools to leverage these capabilities. That's why we built it into the core system. Rick. Rick, you are here tomorrow, right? Rick's on first tomorrow at 8:30. Okay, talk about the propagating the values. This is all, again, the subnet line, the importance of how we're now visualizing these subnetworks, right? This is a very important aspect of data management, workflows, visualization techniques. I showed the find subnetwork tool and what those mean. One thing I didn't highlight when I had it open, that is dirty property again. It's a very important property that defines if a circuit or zone is dirty, right? Because it hasn't been updated. It's all about the trust in the system, because it is very dynamic as we're editing data and maintaining it. How do I know when I do my analytics that what I'm working with is the expectation or the consistent state of the system? So we're trying to provide all these different entry points and report the status if the data is consistent or it needs updating. We talked about how to activate it, screenshot of that, which showed the pop-ups. Also on that dialog, if you don't want to do it based on the spatial intersection, it has the ability to open up essentially a query filter. And by entering a specific query for that subnetwork I want to select. It's also important to understand the type of errors that can occur when updating subnetworks. Right? We can discover invalid lines, devices. If the subnetworks are disjoint, because you said disjoint equals false, so we don't have traversability between those. If we have inconsistent subnetwork names, what happens if that tie switch is closed and now we have traversability between two circuits back to two different subnetwork controllers? Well, we can discover that during tracing, and we discover that during update subnetworks. Because a subnetwork, all of its controllers must have the same subnetwork name. Invalid parent subnetworks for hierarchical domain networks, inconsistent controllers, and so forth. Meaning, for some reason, after I created something as a controller, I changed the asset group or asset type of that specific feature. Well, the system allows you to do that, right? You could create attribute rules, a constraint rule to block that, but we will detect it during update subnetworks if we discover what was stored in our subnetworks table is out of sync with the actual feature. These slides, I'm not going to go into detail. They're there for reference material to show you what the actual error numbers are that you'll see during update subnetworks. Again, for each of these error conditions, we create error features. It's all about reporting what's wrong and giving the user the opportunity to go visit those error features. Dave will show a lot of that tomorrow during validation. It's the information that allows the user then to fix the features to make the data consistent or correct. There are the error codes. Now the last part is the export of the subnetwork. Another very critical part of the system of how the GIS is being used. It's feeding all these other external systems. Eric highlighted the ADMS, the OMS, the DMS, all these other systems. They also are exported into SIM to feed modeling packages and so forth. So when we have the ability then to export a subnetwork in our workflow, maybe every night or every hour, as the circuits are updated in the default version, I've got a process running that's exporting the circuits. Now when I say export, we're writing out the JSON definition of the connectivity of all the features that make up the subnetwork or the circuit. That's what's used, that's then imported into these other systems, right? That's used for all their real-time systems. That's integrated with SCADA, the real-time reporting systems. So we have this way then, a geoprocessing tool to export it. There's the horrible looking JSON that would be a lot of features in there. Most circuits can have up to like 5,000 features. But the purpose there, of course, right? Someone's going to write an integrator, a tool that's going to take that JSON to push it out to those other systems. Some more, these are the actual errors that you'd see when exporting a subnetwork. If a dirty area was discovered. Again, it's the truth and consistency of the system. So this is the case where I'm editing features on my circuit and I maybe posted that to the default version. But those those dirty areas have yet to be validated. So the topology hasn't been updated to reflect those edits. But if we were to trace, and again, Rick will show this, validate consistency during tracing, but during an export of a subnetwork, when we trace the subnetwork and find all the features, if we discover any of those features participate in a dirty area, we're going to fail and give you this error to force you to validate the topology first to make sure everything is consistent before exporting. Because we never want to have the GIS export inconsistent bad data that's going to be loaded into these other systems. That was one of the huge requests by the user community that says, hey, the GIS is the location where all the data entry starts and it feeds these external systems. They spend more time and failing with the data being pulled out of the GIS because the human errors in creating and entering the data that then fails in these external systems. And the loop back expense to send it back to the GIS, have the users redo their work is far too expensive. And it opens up a window to where that real-time system is out of sync with the GIS and the real world. So they can't make the proper business decisions. So you see how we've tried to really harden the utility network model to represent the real world with all these workflows to meet the business requirements. And I'm 2 minutes over, so we have to quickly transition into the wrap-up because I know you all want to go home at 5 o'clock. So it's going to be open for Q&A on anything we discussed today or anything you may want to discuss tomorrow. So the rest of the team is welcome to participate and answer questions as they're hiding in the back. All right, who's going to ask the first question?
I'll ask the question.
Thank you.
So, just going back to when showing the arcade with the subnetwork feature class, you had the bit of arcade script where you were at a different scale, below 20,000 whatever, like draw all, stack all.
Yep.
I thought you said earlier today, I'm trying to understand what actually was happening there. Was there actually, because I thought you said earlier today something about when you do the feeder maps or something, you got an merged version of the data. Like where you,
The geometry. Okay.
yeah.
Yep.
Is that what what is the subnetwork?
Yeah.
Okay.
So Mike's question, two parts, is first to reinforce the definition of the subnetwork and that subnet line feature. It is the aggregated individual geometries, all those lines, So when we update the subnetworks and we do the trace, and we trace out and we know all the linear features, you define what are the valid lines that you want to be aggregated to make up that subnet line feature. And all we're doing is putting them into a geometry bag and unioning them to make one large multi-part feature. So we can get faster visualization, we can do the circuit maps. Then what I was showing on the renderer is that I wanted to leverage the knowledge of having the aggregated subnet line geometry at different scales. I don't want to see it as a circuit map, but I want to see on the map where there are medium voltage lines. A quick way to do that versus rendering the thousands of individual small geometries, just render the 5 large multi-part features. So you can see how much efficiency that is by just pulling back far less data, and we can render it much faster. And I used the arcade expression that knew, hey, when at or below this scale, you render everything with this symbol, which was tagged based on the value of all. That's all that expression is. So I think, I got that directly from Craig Williams on the Pro team with showing arcade examples for advanced renderers on layers. So there's a lot of powerful tricks you can start using arcade for. Mike Miller may not ask a question.
You mentioned network protectors and understanding the direction that they have, like a check valve. How does the trace framework know to go trace downstream through a check valve but not upstream?
So Mike's question is so specific to tracing and how the tracing framework, they will answer that question tomorrow morning. It's funny, again, so much of our system is all built on all these moving pieces together, right? That tracing question is so specific to them. Let's not take up our time. They get to answer that tomorrow. Yes?
I imagine Schneider is jumping in to extend for gas and for electric. Are they jumping in for the water side that all need to service that gas?
Yeah, nice question. Question is, who, besides partners, are we jumping into specific domains to provide functionality and tools that are available through solutions or professional services or in the core? Right now, the landscape is completely open, right? We have many different partners working in all the domains who are building productivity tools, who are building out solutions that are all built on top of this framework. Each of them will do different things. They'll target different tools and workflows where they see the greatest value. Is it on the design side? Is it on the analysis side? Just as well as the solutions team historically has provided tools for different domains. They've always provided an isolation trace for gas networks. Well, they'll continue to do that. And even our long-term roadmap for our backlog about what functionality we build is all based upon user demand and need on what functional areas, to where if partners don't build into that space, but we have to provide our customers something, we'll build towards it in the core. So it's a very difficult question to answer right now. And I think we'll see a lot in the next year. Like you referenced Schneider, they've got their big conference next week, their Link user conference. They're talking about their support of the utility network and the tools they're rolling out in April. So, again, open market right now. Jenny. You're allowed one. Okay, good, nice question. On the topic of propagation and when that happens, with an example of, keep it very simple, a fuse opens. So we've got a fuse assembly which is a bank of 3 different fuses, each fuse representing the A phase, B phase, and C phase. Therefore, our conductor, which is our collection of overhead wires, may have 3 specific wires, 1 for each phase, and the B phase opens. So I need to go into the GIS and edit that individual fuse feature and change its device status to open, right? Then I validate the topology. At this point, if my trace is based on phasing, right, and I trace the circuit and I want to show everything that is still part of that circuit, well, technically, where that fuse popped open, anything that's B phase down line is de-energized. So if you have a line that is a single phase line of energized B, phase B, it's no longer part of your circuit. Your trace at that point would no longer include those line features. Everything from B is de-energized downstream. But that is showing the propagation is working during the trace. The value that gets propagated and stored does not happen until update subnetworks. So now when we run update subnetworks, we know, hey, our trace stopped here at B because it was open. Anything that was B and part of that circuit is now removed and its default value is set to de-energized on the domain value. So that's how we can toggle it. Right, so the question is, how frequently do I run update subnetwork? Well, that's going to be part of these workflows I talked about. So we definitely envision that the default version is where everyone is doing their modeling and their analytics and feeding their external systems, where we'd want jobs that are running every 5 minutes and just validating, and then every 5 minutes updating subnetworks, right, as versions are posted to default. We know these organizations primarily edit within a name version. They do the editing, they do some type of QA, QC on that name version, then they post it to default, knowing it's constructed in the field, it's as built. Therefore, once applied, then do this additional processing. And we have thoughts long term about providing those jobs built into the services architecture. We want to go there real soon. We don't want to see what we saw happen at 8.0 with our versioning system, right? We came out and these organizations had thousands of versions. Well, what was the very first thing they had to have? Some reconcile and post service, right? So several partners, including ourselves, professional services, all built reconcile posting tools that every shop had different customized and all this. So we want to build that into the core long term. You can ask your second question.
Okay, it's about the analytics that you said on subnetwork.
Okay.
Obviously, as you're doing edits, you know, spend line and stuff like that analytics change. Does the change for the subnetwork line only occur when you get to update subnetwork, or does it update as?
Yeah. The same question with when does the updating of the subnetwork line happen, during editing or update subnetworks? It's again during update subnetworks. And I didn't get to go into a lot of detail, so if I'm in a name version and I run update subnetworks, yes, that subnet line will be updated in my version, so I can see it there. Tomorrow when we talk about the versioning and reconcile and post, there are some things that don't get reconciled and posted, like the subnet line, or your dirty areas, or your line error features, or your topology. That's all lost during a reconcile. So that's part of the workflow is after I post, yes, I have to rerun update subnetworks because essentially we're merging 2 states of the system into one. Yes, one more.
Okay. You mentioned that there are 2 unique ways to build the database and then now, name features are usually the person. So how do you suggest organizations handle it from that particular person?
Oh, nice question. So with identity, right, we talked about this morning that there's the database schema user, which is your database connection user that owns the data. All these feature classes are stored in that schema in the database, the geodatabase. Then there's the identity that's used that's required that will be used when creating the utility network, because we're going to store that identity, because that identity is really an admin type of user. And that's required when publishing. It's going to be required for many of the REST endpoints, because don't forget things like disabling the topology. Only the identity owner may disable the topology. Well, it's not the database schema user, so when you call the REST endpoint, you have to pass your credentials, and we're verifying that you are the owner of the utility network. Now, you asked, what does it mean that that user then has to be tied to some actual person in the organization? That is true. It's no different than any other items that you create in your portal and share. There's essentially some type of owner, right? One of the things that we don't have in the first release, I don't think it's critical in the first release, but we can easily add it in a future release, the ability to change the owner of the utility network based on the identity, right? So if I want to hand off my items, it can then be handed off to Gmon. So if that's a big issue. So we'll get there when there's pressure in requiring that. Any questions online? Oh, we got another one.
So just in terms of, you were mentioning some of the previously returned quite a few features. Have you changed the max record count at all on any web services that you publish, or is it still at the 3,000?
Changing for the SOCs, the max record counts for the service. We have not changed any. You know, it's still just a feature service. Now, this is where I'm drawing a blank. There's been many discussions and meetings for point classes to increase the load, increase the max record count there. And I can't remember if they've done that. But again, it's just a configuration on the service. Personally, I don't see a value in doing that. Why that was critical previously, years back, is because we didn't have pagination. Now that server started supporting pagination several releases ago, 2 releases ago, our client applications are leveraging pagination. So it knows the record count, so it'll ask for a page of values up to 2,000. If it gets it, it knows if it needs to go back to request more to get the next page. So we've made a lot of efficiencies in the stack to leverage that knowledge. So max record count kind of is not critical. No more questions. Oh, man. You're from ESR Canada as well, aren't you? It's always the Canadians. Crawford, what is it with you guys?
We're interested.
Yeah.
And interesting.
Yes.
So just in terms of your definitions for domain networks, so kind of a two-part question. You have 2 different domain networks in the same utility network that have different tier definitions, and if so, is there kind of a use case that you have in mind for that?
Right. So within the same domain network, having multiple tiers with different tier definitions.
So 2 domain networks within the same utility network, each domain network has a different tier definition. So one partition is there.
Yes. Yeah, definitely, because we do have organizations who manage multiple different domains. Many of the smaller co-ops manage electric and water. So they'll have their electric domain network that's partitioned. They'll have their water, which is hierarchical, and of course they have the structure network. And that was Eric's example, tracing between those, finding those type of things. So yeah, that's one of the main reasons to be able to support all the different domain networks.